Okay, so tonight's lesson starts us in chapter 10, which is on roots, radicals, square roots. We'll be doing complex numbers in this chapter. This chapter goes for a while. It's several sections, and we will cover 2 sections tonight and probably 2, I think it's 2 each night until we finish it. It will be lengthy. It's very important that you understand everything that's in this section. So we're going to start with talking about what does it mean to take the square root of something. So when you're looking for a square root, that means that you are looking for a number when multiplied by itself equals whatever you're taking the square root of. Okay? So I don't have the proper definition in my workbook here, but if I asked you what is the square root of 64? What is the square root of 64? Well, what number times itself equals 64? 8. So the square root of 64 is 8. Now, we use this notation, which is called a radical, to indicate that we're taking the square root of 64. When they first introduce this to you, they don't talk about that sign, okay? They just say, what's the square root of 64? And you say 8. Now, there's another number that can be the square root of 64. What's another square root of 64? Negative 8. Because if we're talking about this one, 8 times 8 makes 64. And this one, negative 8 times negative 8 also makes 64, doesn't it? So how are you going to know when they want the positive root or the negative root? So I'll tell you that shortly, okay? How you're going to know when they want which one. Can you take the square root of a negative number? So does negative 81 have a square root? So I hear no. Why? Okay, because a negative times a negative is a positive. And a positive times a positive is a positive. And anytime you square something, you have to multiply it by itself, right? So you cannot take the square root of a negative number. Okay? Now later in this chapter, we're going to discuss complex numbers, which are imaginary numbers, which are square roots of negative numbers. And then you'll actually have a way to represent that answer, but not really be talking about a real number. That's why they're called imaginary. Okay, so that'll be a little bit later on in this chapter. If they want you to give them, and I say they, referring to your textbook, the problems you're working, if they want you to give them the positive square root of the number, they will not put a sign in front of the radical. So if I put this, that means I want the positive answer. It's called the principal square root. If they put a negative in front of that, they want you to give them the negative answer. This is very standard through all textbooks. So you should be good to go if you know that this means they want the positive and this means they want the negative. If they ask you to take the square root of a fraction, students have a hard time with this for some reason when they first see it. But it simply means take the square root of the numerator and the square root of the denominator, okay? What's the square root of 25? So this means the square root of 25 over the square root of 49. What's the square root of 25? 5. What's the square root of 49? 7. So that answer is 5/7. Now you can't do this. This is not a real number. So I'm not sure how your book will signify that answer, but I would just write does not exist. D&E. But you can do this one, right? Because the negative is outside the radical, so that answer is -2. What about 0? What's the square root of 0? What is it? 0. So let's make a point of something as well. As we call this little symbol the square root, I want you to make sure that you do not ever, 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 ever forget there is an understood 2 there. That's your square root, okay? There's an understood 2 there. So it means what number times itself twice gives you the number that's under the radical. That's called the radicand. So what number times itself twice gives me 49? That's what that means, okay? We don't write the 2 there because this is called a square root, but you will see other numbers written there. This is called your index, by the way. So you'll see other numbers in your index, and those will tell you that you're not taking the square root. You might be taking the 3rd root, which is called the cube root, or the 4th root, or the 5th root, okay? You can also take square roots of decimals. You'll want to utilize your calculator on some of these things if you're having any trouble at all. Don't be afraid to use your calculator. So what number times itself is 0.25? 0.5. And you can write 0.5 if you want to. Now, you cannot take, you might want to make a note of this, even roots of negative numbers do not exist. But odd roots of negative numbers do exist. Which leads me into if I wanted to do the cubed root of 125. So now I'm asking myself, what number times itself 3 times makes 125? What? 5. 5 times 5 times 5 is 125. Now let's put a negative on that. The cubed root of negative 125. So if that had been the square root or any even root, 4th root, 6th root, whatever, I couldn't do it. Because when you multiply a negative times itself an even number of times, you're always going to get a positive. But this is an odd root. Negative 5 times negative 5 is positive 25 times another negative 5 makes negative 125, right? So this answer is negative 5. It is handy for you to know the first 13 or so perfect square numbers just because you use them so much. They're listed for you in your workbook on page 372. The first 13 are listed there, and that's pretty standard. And then the first 5 perfect cubes and 5 perfect 4th powers. Those are all good ones to know. You don't have to memorize them, but they're handy. And if you have a lot more math classes to take, you really probably should memorize them. Okay? Okay, can I take the cubed root of 64? Well, sure I can. What is the cubed root of 64? So if you have your calculator, this would be a good time to learn that function. If you do not, you're going to need to make sure that you can learn it. You can either Google it or you can ask me about it when you have it with you one night. But you can Google anything, you know. So you could. I've never thought about actually Googling how to use my calculator, but I'm sure you can look it up. So do you know how to do it? Okay, so let me see that one because I think that's what most everybody has. So you're looking on this calculator for, you see the housetop key, it's the fifth button down on the left. Above it is a function that says the xth root of. So you would type in the cubed root, so you put a 3 and then hit second in that function, and then type in your radicand of 64 and hit equal. And it'll give you the answer. So the first number you have to put in is what your index is. Okay? Anybody else need help? Okay, so what's the answer to this? 4. 4 times 4 times 4. Okay, this one's an interesting one. What about the cubed root of negative 1 over 27? So I can take the cubed root of a negative. It'll be a negative, won't it? Okay, and then I'm supposed to take the cubed root of the top number and the bottom number. So what's the cubed root of 1? 1, and what's the cubed root of 27? 3. So the answer to that is negative 1/3. Now, I like to teach my roots of variable expressions probably a little differently than the textbook would show you if you have the textbook. I go about it in terms of rational expressions, rational exponents. This is not the best one to start with, so, well, it is the best one to start with, but not following what I just said, so hold that thought for just a minute, and let's just look at this. If I asked you for the cubed root of x cubed, the cubed root of x cubed, what number times itself 3 times makes x to the 3rd power? X. Now I'm going to write this exponent in blue. The way that you can justify this, if this were not something so simple, would be to divide the power by the index. And 3 divided by 3 is x to the 1st, which is just x. So it's the power divided by the index. Now that helps me when I get into harder problems. But let's do a few more of these simple ones. What if I asked you for the square root of x squared? Square root of x squared. This is an understood 2. What's the square root of x squared? Just x, right? Now we're about to get into like where we're hoping we're seeing a pattern here. What's the square root of y to the 4th? I'm sorry, the 4th root of y to the 4th. Y, okay. What about the 5th root of x to the 5th? X. So are you seeing that if the index and the exponent are the same, that the answer is just whatever the radicand is, whatever's underneath there? So if I gave you the 5th root of c plus d in a quantity, all raised to the 5th. Just c plus d, right? So the 5 divided by the 5 would give you the 1, and that's why you would just have whatever was underneath there. Now, with all that being said, we have to add a little something to this. So number 11, where it says 4 roots, this is on page 373 in your workbook. It says for roots with an even index, we require the answer to be what? 4 roots with an even index we require the answer to be positive. For roots with an even index, we require the answer to be positive. So, we usually will put absolute value bars around our answer to ensure that it was positive to begin with, because we can't take the square root of a negative number, right? Well, you can't take an even root, any even root of a negative number. So if it's an even index, so if the root, which is the index out here, is even, we will require that the answer be positive. For instance, if you have the 5th root of y to the 5th, which I already did one like this, the answer is just y. The index was not even, so I don't have to worry about whether it was positive or not to begin with. But if I look at this one, 9x minus 2 squared, the square root of anything squared is just that anything. You have to put bars around it because you took the even root of it. Now, it really only applies if you get an odd-powered answer. So we actually could take this a little bit further. That this means we will put absolute value bars, and I don't see this in your workbook, so that's why I'm giving it to you. Okay, so you're going to put absolute value bars. We'll just say put the absolute value sign around your answer. If the even root results in an odd-powered answer. If it's an even-powered answer, it's going to undo itself. So there's no need to have them. So only if, you see how this was an even root of something. Don't even worry about the power in here. But the power on the answer was 9x minus 2 to the first, and the 1 is an odd number, so you need to put bars around it. So if you had gotten 9x minus 2 to the 6th, you would not need to put bars around it because it's even, and that takes care of it undoing any negative possibilities. But if it's 9x minus 2 to the 3rd, you would have to put bars around it. So if the answer, if you start with an even root and you end up with an odd-powered answer, you have to put absolute value bars around it. That's one of those little nitpicky things that some teachers don't really talk about, but at this level you need to know when to do that. Okay, so what if I gave you the square root of t to the 6th? Now, like I said, I like to think about this in terms of division. So I would rewrite this as t to the 6 divided by, what's the index out here? 2. So the answer is t to the 3rd. That is actually a rule for rational exponents that we're going to get later in the chapter, but I think it's handy just to go ahead and start teaching it here. It doesn't require you to make any guesswork on it. Now, I had an even root, a square root, and I got an odd powered answer, didn't I? So you have to put bars around this. All right, what about the square root of 25w squared? Okay, what's the square root of 25? 5. And what's the square root of w squared? W. Now, I don't need absolute value bars around the 5 because 5 is a positive number, right? But I am going to need them around this w because I had an even root and I got an odd powered answer. It's w to the 1st. It is. It's 5 times the absolute value of w. So if w were -1, then the answer to this would be 5 times the absolute value of -1, which is 1. So the answer to this would be 5. If it was 2, it would be 5 times 2, which is 10. Okay? I mean, you could throw anything in there. But you just have to put the absolute value bars around it because of the fact that you have to ensure that it's a positive number in order to have it underneath an even root. Can't take the even root of a negative number. Okay, so this takes care of any problems with this being negative to begin with. This should take care of it, squaring it, but you have to ensure, it's just one of those things you have to ensure it. Because 5 is positive. 5 is 5. So Ronnie said, why wouldn't you put 5 inside the absolute value bars? Well, 5 is already a positive number. So I don't need to put absolute value bars around something that's already positive. I only have to put it around this because I don't know what it is. We'll try to talk about it some more. Let's change colors. Okay, what about, and as I look at that one, I think I probably, because it was squared under here to begin with, I probably could do without them. Trying to think. If w were -1, then you would square it. This might be one of those where you could do without it. This is the rule, though. Put absolute value sign around your answer if the even root results in an odd powered answer. But I probably should say around your variable, because you have to use your common sense about the number part of it. All right, let's look at another one. I know these are confusing. The 5th root of 32a to the 15th. The 5th root of 32a to the 15th power. Now you're just going to take the 5th root of each part. So what's the 5th root of 32? Use your calculator. What's the 5th root of 32? What number times itself 5 times makes 32? 2. Okay, and then as far as the variable goes, I taught you to take the power and divide it by the index, right? So the answer to this is 2a to the third. Now, I do not need absolute value bars because this was not an even index, was it? You have to start with an even index to have to use the absolute value bars. All right, they do a quick review of the Pythagorean theorem. I assume it's a review. Did you guys use the Pythagorean theorem in your last math class? You did? You took it here? Okay. All right, so this is a review of the Pythagorean theorem. Just jot it down. I hate that they use A, B, and C because students get really caught up on A squared plus B squared equals C squared. I had a student at my desk today that recited that to me, proclaiming that he remembered everything from geometry. But what's going to happen is he's going to get on a standardized test and they're not going to call it A, B, and C. And when that's the case, you have to be flexible and you have to understand, what does A squared plus B squared equals C squared mean? Well, Pythagoras discovered that the square of the hypotenuse was equal to the sum of the squares of the legs of any right triangle. It happened every time. Okay, so if we draw a right triangle with a missing side on it, and again, do not get hung up on A, B, and C. You need to make sure you understand that the hypotenuse is the longest leg and it's located across from the right angle. And we're looking for this one, and then this one is 5 inches. And I love it that they didn't call it A or B, they just called it question mark. Okay? So we're going to set this up as C squared equals A squared plus B squared. I know some of you do A squared plus B squared equals C squared. Either way is fine. But the hypotenuse, the longest leg is 13. So 13 squared equals 5 squared plus question mark squared. Let's just go with that. 13 squared, I know mine, it's 169 equals 25 plus question mark squared. Subtract 25 from both sides. You'll get 144 equals question mark squared. You're going to square root both sides. And the question mark is 12. So that side is 12 inches. Okay? Just a quick review on Pythagorean theorem for you. Now, we're going to talk about graphing radical functions. This is one of those things that can be a little tricky. But if you just keep in mind that you cannot take the square root of a negative number, then you are really going to be fine. I'm going to get me some graph paper up. Okay. So if I asked you to graph f of x equals the square root of x. So to do this, you have to make a table of values of numbers that you can put into the function for x. Now, where am I going to get these x values? From my head. I'm going to make them up. I'm going to put in x values that I can take the square root of. You can use ones that don't have perfect square roots if you don't want to. If you want to. Okay, so if you wanted to put 3 in there, you could. I'm just going to pick some that are going to be easy for me to do. But quickly, can I choose a negative number to go in for x? Can I take the square root of negative 1? So that would be f of x equals the square root of negative 1. Can I do this? No. No solution. Does not exist. Whatever. Just mark it out. It's not going to work. You can't take the square root of negative numbers. So you can't choose negative x values to go in there. So that means there will be no negative x values on this particular graph. I can take the square root of 0. I can take the square root of 1. I can take the square root of 2. I'm going to get a decimal if I do that. So I'm going to skip that one. I'm going to go to one more that I know is pretty easy to do. What's the square root of 0? It's 0. So this ordered pair is 0, 0, which would be right here. Then I'm going to put 1 into the function. What's the square root of 1? 1. So this ordered pair is 1, 1, right? That's a 1, sorry. Okay, what's the square root of 4? 2. So this ordered pair is 4, 2. So 0, 0, 1, 1, 4, 2. Could I keep picking positive x values to go in there? Sure. I could put as many as I wanted to, couldn't I? Couldn't I take the square root of 100? But do I want my x-axis to have to go all the way out to 100? No. So I'm going to stop there. I'm going to connect them and put an arrow on the end to show that it goes on forever and ever. All right, what if I said let's do the cubed root of x? So f of x equals the cubed root of x. Okay, can I take the cubed root of negative numbers? Yes. So with this, my x values are not restricted. So I can pick any numbers to go in for x. Let's do choose ones that we know we can take the cubed root of. So I'm going to choose, and I'm going to choose an array of negatives and positives. So I'm going to go with negative 8, because I know I can take the cubed root of 8 as 2, right? So the cubed root of negative 8 is negative 2. So I can do that one. I'm going to choose negative 1, and I'm going to choose 0, and I'm going to choose 1, I'm going to choose 8. I mean, I could do more, but that's really enough. So the cubed root of negative 8 is negative 2. The cubed root of negative 1 is negative 1. The cubed root of 0 is 0. The cubed root of 1 is 1. And the cubed root of 8 is 2. So my order pairs are negative 8, negative 2. Now I think this one only goes out to 7. So I'm going to go ahead and guess where it's at. So negative 8, negative 2. Right here. Negative 1, negative 1. 0, 0. 1, 1. And 8, 2. So this one looks like this. Now, how can I talk about determining the domain of a rational function? Did you notice there were only certain things that I could put under this radical because it was a square root? What could I only put under this radical? Positive numbers and 0, right? So I could choose any numbers that were, this is called my domain. The x's that I can choose are called my domain. So I could choose any numbers that were greater than or equal to 0 for that function. Is that right? What about for this function? I was able to choose what? Any number, positive numbers and negative numbers. So the domain on this was all real numbers. I'm not really sure how your book is going to notate it, but I think they're going to give you negative infinity to positive infinity. Okay? So I could have chosen any x value to substitute in and gotten a y answer or an f of x answer. Remember, this is your x-axis, and if it's in function notation, that's your f of x-axis. Okay? So the domain is based on what x's can be chosen and evaluated in that function. If I gave you this function, and I just simply asked you, what is the domain? What is the domain of this function? So I know I can only take square roots of numbers that are 0 or better. Is that right? 0 or greater? Okay. So what you have to do in a situation with a square root is you have to take what is under there. So you're going to take the radicand, and you are going to set it greater than or equal to 0. Because isn't that what has to be true? That this x plus 2 has to be greater than or equal to 0? And then you are going to solve that for x. So simply just subtract 2 from both sides, and you'll get that x has to be greater than or equal to negative 2. That's your domain, that you could put in negative 2 or bigger. So my domain then is from negative 2 to infinity. if it's a cube root function, so if this is f of x equals the cubed root of x minus 2, you can take the cubed root of any number, can't you? So this is always going to be from negative infinity to positive infinity. Your domain is always going to be that. Because I can cube root any number. I can take an odd root of any number. I just cannot take an even root of any number. Okay? Any questions? All right, let's do one more. See if I can find a space to squeeze it in. So I've gotten to the bottom where it's not going to let me move anymore. Oh, here we go. I got enough right here. Okay, that'll be fine. All right, so I'm going to graph f of x equals the square root of 4 minus x. I'm going to write the domain in interval notation, so I have to tell what the domain is. I have to make a table of values to graph it. And then I have to graph it on this coordinate plane. Now, the first thing you have to do is you have to decide what numbers you can put in for x, okay? Because this is a square root. So if you're taking the square root or an even root, then you take the radicand and you say, well, this stuff underneath the radical must be greater than or equal to 0. It has to be, because I'm taking a square root. I would subtract 4 from both sides of this inequality. And then you're going to divide both sides by the negative 1. Now, when you divide by the negative 1 coefficient of x, you have to remember to flip that inequality sign around. So that's from way back when that you have to be careful and remember that. Okay? So this one's a little different. This says that my x's can be less than or equal to 4 because I'm subtracting x. That's why. Okay? So I can choose 4 and anything that's less than or equal to 4. So what are some numbers less than or equal to 4 besides 4? What are some numbers less than 4? 3? I could do 0. I can do a negative number if I want to, can I? Can I? 4 minus a negative. Let's do one of those. Let's choose negative 1. As long as it's less than or equal to 4, it's fine. So my domain is all the x values that are less than or equal to 4. That means from negative infinity to positive 4. And it includes it, because I can put 4 in there and get the square root of 0. So this becomes the square root of 4 minus 4, which is the square root of 0. Which is just 0. So that order pair is 4, 0. Then I can put 3 in there. The square root of 4 minus 3. That's the square root of 1, which is 1. So that order pair is 3, 1. The square root of 4 minus 0 is the square root of 4, which is 2. So that ordered pair is 0, 2. The square root of 4 minus negative 1. What's a minus a negative? Addition. So that's 4 plus 1, right? So you can do the little where you change it to plus plus. That's the square root of 5. And the square root of 5 is what? Approximately 2 point what? Somebody help me out here. 2 point. Thanks. So that order pair would be negative 1, 2.2. You can just estimate it. So this one goes on forever and ever that way. I can't put an arrow on this end because that would mean that I was choosing x values that were greater than 4, and I found out right here that x must be less than or equal to negative 4 in order to be square rootable. Okay? Okay, we're going to take just a second or two break.